Alright, so today's discussion will be about logarithmic equations, and there's just a few styles of logarithmic equations, some with a couple of logs and numbers, and some with only logarithms. In the end, the definition of logarithms is going to come in handy, as well as the sum and difference rules for logarithms. I'll write them out right here. Remember that the log a of m minus log a of n can be rewritten as a single logarithm, log a of m over n, where m is in the numerator and n is in the denominator because n has a negative number in front of it. Or if it's a sum, it can be rewritten as log a of n times m. So if they're added, you can take the sum of them. If they're subtracted, you can take the difference, making sure that the one with the negative sign is in the numerator. Sorry, denominator. So let's begin with this one. It looks complicated, but in the end, this first law is actually going to help us quite a bit. Notice I have a log base square root of 2 and minus another log base square root of 2. This can be rewritten as a single logarithm. Logarithm square root of 2 with a single argument where 2m minus 4 goes in the numerator and m minus 1 goes in the denominator, and this is still equal to 4. Now notice I have a single logarithm, and so I can apply the definition of logarithms. Definition of logarithms says that this number raised to this power should equal this number here. And so square root of 2 raised to the 4th power should equal 2m minus 1 over m minus 1. And then, so if I take the square root of 2, raise it to the 4th power, I believe I get 4. But let's check that for sure. The square root of, I'll do it off to the side here. The square root of 2 to the 4th power. I'm going to rewrite this as the 2 to the 1/2 to the 4th power. Then I will multiply these together, and it will be 4 times 1/2 is 2, 2 to the 2, which is 4. So square root of 2 to the 4th power is actually 4. And so I'll write that as a 4. And this is 2m minus 1 and m minus 1. Now if I take and multiply both sides by m minus 1, this is basic algebra. The m minus 1's cancel, and I get 4m minus 1 is equal to 2m minus 1. Now if I add 1 to both sides, all of those cancel, and I've got 4m is equal to 2m. If I subtract a 2m from this side and a 2m from this side, I've got 2m is equal to 0, and in the end I get m equals 0. I think I did that correctly. Let's see, subtract a 2m, subtract a 2m, and looks pretty good. And so basically the only way to make all of this equivalent up top here is to have a 0 placed in for m and m. So that's one of the styles of logarithmic equations. I have another one here with, that was with 2 logs and a number. This one is just 2 logs. And this one can be done, oh wait, this is also 2 logs and a number. Let me just erase that number and do only 2 logs. This one's going to be pretty simple. Turns out log of 2 of x minus 5 equals log of 2 of 3x plus 4. These logs of 2's will cancel, and you've got x minus 5 and 3x plus 4 immediately. And so you subtract an x, subtract an x, subtract a 4, subtract a 4. I got negative 9 is equal to a 2x, and I've got x is equal to a negative 9 halves. Okay. Let's put another one up just because that one was pretty simple. What if we've got 3 halves is equal to 2 log of I had a sample in the sample test, so let's do something similar to the one on the sample test. Log of third root w squared minus 10w. This is from the sample test. And now basically a lot of what is happening here is you have to understand what's going on with this thing. Like, this is, if you were to read this, you would see that there's no base written here, so it's automatically a base 10. And then the argument for the logarithm is the thing that follows it. So the argument for the logarithm is the root 3 of all of this. So what I'm going to do is I'm going to try and employ the power rule here to get rid of this root 3, because it's going to be a little bit of an issue, I think, if I try it a different way. So there's my argument, and it's raised to the 1/3 power. Okay, and now I'll take this 1/3 power and I'll bring it down to the front due to the power rule. 2/3 log of w squared minus 10w. And now I'm ready to go. Remember, when you isolate variables inside of a logarithm, you have to get rid of this c first, which it looks like it's already done, then the a, then you perform the definition of logarithms, then you work on this stuff here. So I'll get rid of the 2/3 right now by multiplying by 3 halves on both sides times 3 halves. Remembering that this is all one thing, and so 2 times 3 and 2 times 3 is 6/6, and this all cancels, leaving you all of this logarithm of w squared minus 10w, and this is 9/4. And now we must apply the definition of logarithms. Once you get down to here, it's pretty simple. So we would say 10 raised to this power, 10 to the 9/4, should be equal to w squared minus 10w. And 10 to the 9/4. Now we notice that we have a quadratic, and so we're going to have to employ the quadratic formula here. And so I'll say, in order to employ the quadratic formula, we have to set the equation equal to 0 minus 10 to the 9/4. And so my a value is 1, my b value is negative 10, my c value is a negative 10 to the 9/4. And so w, the variable that I'm looking for, should be equal to a negative b plus or minus the square root of b squared minus 4ac over 2a. And so if I plug in all of these things, I'll get the answer. I'll just quickly plug them in here. Negative 10 plus or minus the square root of a negative 10 squared minus 4 times a, which is a 1, times c, which is a negative 10 to the 9 fourths, all over 2a, which is just 2 times 1. So I will first take the discriminant here, which is the thing inside, and try and simplify this. So that would be negative 10, which is negative 10 squared, which is 100, minus 4. It's actually going to be plus, because I have a minus and a minus. I forgot my parentheses there. So this all should be multiplication. Remember, it's 4 times a times c, so 4 times a times c. And so a negative and a negative become a positive, and 4, this becomes 4 times 10 to the 9 fourths. And 10 to the 9 fourths, I actually don't know what it is, so I will do that here. 4 times 10 to the 9 fourths looks to be about 711. If I add that extra 100 to it, plus 100, it's 811. And if I take the square root of it, by doing the square root of the answer, I get 28.5 or so. So w is equal to a negative 10 plus or minus 28.5 all over 2. And so you can then simplify this down here. This would be negative 10 minus 28.5. So it would be a negative 38.5 halves, or a 18.5 halves. Okay, and so that's a couple of the logarithmic equations for this chapter.